The death of a massive star. What could be more epic? More fascinating? But do they die? Can they? Does something take its place even more interesting? More misunderstood? Not too long ago, it was thought that these stellar remains were sent from distant civilizations. Is it true? All in good time. To start, let's remember some information that is well known among astronomers about the death of stars that are a few times bigger than the Sun. After an unimaginably powerful explosion, the star expels huge clouds of gas into the void of space and collapses in on itself to a tiny ball, infinitesimal when compared to what it used to be, made of now a mass of protons and neutrons so tightly packed together it's as if they are glued. The remains of the star are now made of different stuff. Neutrons, after which the new stars are named. Neutron stars are not just a particular kind of star, but actually a sort of in-between level between stars and black holes, riding the fine line which, when crossed, causes the neutron star to collapse in on itself and turn into one of the dark monsters of the universe, all devouring and letting nothing escape, not even light. But that is not the only reason a neutron star is so fascinating. They are so difficult to understand, we haven't been able to figure out how to recreate the conditions in a lab necessary for their formation. They are huge stars of diameters ranging from that of more than 1,000 suns to the size of a small city. Just 20 to 30 kilometers. They are absolutely massive. 2 or more times more massive than regular stars. When one of the star's cores collapses as a result of electron penetration in the nucleus of atoms, creating neutrons as a result of the extreme pressures there. It is for this reason that just a teaspoon-sized sample of the stuff neutron stars are made of was possible to have here on Earth. It would weigh hundreds of millions of tons. Its density is greater than the density of an atomic core. But how do neutron stars become pulsars? Scientists have been trying to explain this phenomenon for a long time. As far as we know, all stars turn around their axis. The Sun, for example, makes one rotation about every 25 days. But if a titanic star much larger than the Sun was suddenly compressed, its rotation would astronomically, HA, increase. It can increase the speed of rotation to be a whopping quadrillion times faster than before. This immense change in speed of rotation is illustrated well by a figure skater. When they pull their arms in close to their body, the speed of their turning on the ice is noticeably increased. A pulsar the size of New York might spin with a speed of 1 rotation per second. But there are some pulsars that spin with unimaginable speed, more than 1,000 rotations per second. This is the very reason for their emissions. The speed of the regions on the magnetic poles of a pulsar are so great that they start to emit energy in the form of radio waves, X-rays, and gamma rays. So long as a pulsar rotates with a source of radiation, magnetic poles, we see its flickering light, like a lighthouse in the universe whose light is constantly moving. It is important to note that the voltage of one is around 30 million times greater than lightning on Earth. How does modern science know all of this? In the summer of 1967, a doctorate student at Cambridge University by the name of Jocelyn Bell discovered the first pulsar which regularly emitted energy every 1.33 seconds. But information about it was kept secret for a long time. Why, you ask? It isn't hard to guess if you keep in mind that they called their discovery LGM-1, which stands for Little Green Men. The signal that was coming from the depths of the universe with such surprising and consistent regularity was mistaken as an attempt of communication by some alien civilization. A year later, after several other similar sources of radiation, the scientists decided to release their discoveries all at once, rather than send the world into shock. A scientific sensation ensued, and everyone stopped what they were doing to find a telescope and look for new cosmic lighthouses. But the illusion was short-lived. After more detailed study, astrophysicists came to the conclusion that pulsars weren't anything more than neutron stars that were emitting the different forms of radiation with their incredible rates of rotation. If radio pulsars emit radiation using the energy from their rotation, then Z-ray pulsars, like the one in the Crab Nebula, all that remains after the supernova in the 9th century, use energy from surrounding stars. But the plasma of neighboring stars isn't enough to overcome the strong magnetic pull of the pulsar. As a result, the plasma gets caught in the pull and hits the surface of the neutron star and starts to emit X-rays. Also, X-ray emitting pulsars spin much faster than the others, hundreds of times per second. Slowly, over time, their activity decreases, and in their old age, they flicker much less often. These fascinating unstudied cosmic lighthouses will occupy the minds of astronomers all over the world for a long time to come. It is truly disappointing that they aren't actually signals of little green men. Are we really absolutely alone in the universe? What do you think? For more detailed explanation, we have written an article on our page on BK. The link is in the description. Go check it out after liking and subscribing to our channel. You'll find it quite entertaining.